Well, thank you guys all for your guesses, and I'm going to reveal that the correct answer in this case was that it was heat buildup. So anybody who was guessing heat buildup, you turn out to be right. There were many other good guesses. I'll go through some of the guesses and give you my thoughts on them. But what happened was I had installed the video transmitter with the metal cover, which also acts to dissipate heat, up against the carbon fiber top plate, so I could have the switches facing down. And my thinking was that the carbon fiber top plate would, I hoped that it might actually help dissipate the heat. Carbon fiber is a very good conductor, right? So I thought, well, maybe some of the heat from this will actually dissipate into the carbon fiber plate and I won't have an issue with lack of airflow. But that did not work that way. It did not work that way at all. So when I first turned it on, as I say here, it looked fine, and then it got progressively worse over time until it was completely static. And that, of course, was it heating up. Then when I unplugged the battery and replugged it immediately, it was still hot, so the problem didn't go away. When I unplugged it and waited a minute, it looked fine, and then it went bad again because it had had a chance to cool down, and then it heated up again. Okay, so let's work through some of these answers. So the guess is overheating. Maybe in part to a mismatched SMA or RPSMA. Now that's a very good guess. If you have an SMA connector, it will not have a pin on the video transmitter. And if you have an RPSMA antenna, it will not have a pin on the antenna. And if you plug them in together, they will screw together. And in fact, you will actually get some amount of transmission through the antenna, even though there's no pin on the inside. The signal will sort of jump the gap, but it will not have the correct impedance, and you will get a heat up. So that is actually a really common thing. Well, maybe not like super common, but it is a thing that can happen. And it's one of the reasons why I like RPSMA connectors on video transmitters, because the pin being on the video transmitter means that it is impossible for you to plug the wrong kind of antenna in. If you try and plug an SMA antenna into an RPSMA transmitter, the pins will bang together and they won't go together. Whereas the other way around, you can screw it together and have a bad condition. Overheating video transmitter, correct. Video transmitter too hot. One of those cheapy pigtail extenders being faulty. That's a good one too. If you have a bad pigtail or a faulty pigtail with a broken, either a broken signal pin or a broken ground line, then the impedance won't be right, the current won't be able to flow, and it can be almost as if you didn't have an antenna at all. Overheating video transmitter, that is the correct answer. Let's see. Yep, that's exactly right. You nailed it. Ron Wilson, Peter Boss, you guys both nailed it. Changing the LiPo would be the first move. So I guess this guess depends on there being low battery. And that's possible. You could have a scenario where the battery had just enough power to power you up, but then it started going low. And if you're feeding it off a voltage regulator, it could drop out. And then as you unplug it, the battery could recover slightly. That's a decent guess. This one, I don't know. This one, there were many guesses that could have been the result of RF interference or RF issues. But one thing is that, I mean, they're right next, they're like 2 feet away, 1 foot away on the desk. So even with no antenna at all, and in fact, they didn't have any antennas at all on the receiver, but the signal was crystal clear. But the other thing is the way that the signal slowly degrades over time and is dependent on how long the radio has been plugged in doesn't seem consistent with like an RF issue like the Fresnel zone being blocked or something like that. FPV Portugal, got it correct, too hot. Different channels. Now this is an interesting one because what we've got here could be different channels. And in fact, someone further down suggested that we could have a scenario where as it heats up, it shifts its center frequency. And that is something that can happen. But in general, I would expect if they were on just completely on different channels, I wouldn't expect to ever see a clear signal. Like it would always be bad. That's what I've had in my experience when they're on slightly, you're like on, one of you's on A band and one of you's on E band or I don't know what, and you're just slightly on, 5 megahertz off, so it's always bad. Paul R. Scott, yep, got it. Absence of a common ground. Now that's an interesting one. I wonder if that would cause the kind of drift that we see. Don't know. Too close to the receiver is an interesting one. You wouldn't think that having a transmitter too close to a receiver could cause a problem. But there's this thing called front-end saturation, where if you have them too close together, it can like overdrive the front-end amplifier, and you can actually get bad signal corruption. I'm not sure that that's something that's going to happen very often with our devices. Maybe if you had like a 1 watt or a 5 watt video transmitter, you could get overdrive the front end amplifier, but I don't think that's likely to happen with 200 milliwatts. And also, again, in that case, I would definitely expect it to be, I wouldn't expect it to progress the way that it did, personally. Now, this is a silly guess, but actually microwaves operate in 2.4 gigahertz, not 5.8 gigahertz. Now, I didn't tell you the frequency I was in, but it's a fair guess it was 5.8 gigahertz. So if this was 2.4 gigahertz and my wife was turning the microwave on and off, maybe, right? But then we would expect to see it sort of sharply come and go as the microwave went on and off. Ungrounded audio wires. IB Crazy did a thing where he said that audio wires need to be grounded. It turns out that some transmitters, it doesn't matter. And ungrounded audio wires will result in slightly more chance of you interfering with a nearby device on an adjacent channel, but it doesn't affect your signal, especially because there's nobody else around me. Let's see. And there was one more guess that I was hoping to get to, and that's the capacitor. And I liked this guess very, also sharp eyes, noticing the capacitor at all, but also that was my first guess too. My first guess, because if you think about how a capacitor charges up and discharges, when you first power it up, it sort of charges up, and then when you power it down, it loses charge slowly over time. My first guess was that I just didn't think of overheating. I just didn't think of it because I was sure that overheating wasn't going to be an issue for me, and of course I was wrong. But I also guessed the capacitor first and actually desoldered the capacitor from the board. Didn't solve the problem, and I put it back. But that guess, that was the first thing I thought of as well. Alrighty, well, that turns out to have been the correct answer this time. Hope you liked this little bit of trivia. This was not, I mean, the overheating video transmitter causing this issue. This is the first copter I've built with a TS5823, and I had been using a 250 milliwatt Fat Shark transmitter, which of course is much bigger and heavier, but also a little more robust than these tiny little things. And so I hadn't had a problem with overheating just because the Fat Shark has a lot more ability to dissipate heat, and I could kind of mount it any which way I wanted. It kind of didn't matter. So this is what it looks like when your video transmitter is overheating. And basically, even after I flipped it over, I still don't like to leave it running too long on the bench without air moving over it. If I turn the copter on and I just let it sit at the field for like 10 minutes, the video will start to get a little sketchy. So that was what led me to do the range test on the FPV video pigtails, because this did have that right angle pigtail on it, and I thought that the right angle pigtail could be causing more energy to reflect back. So I actually swapped it out to the straight pigtail in hopes that that would reduce some of the heat buildup. I don't know. There you go. Hope that was interesting to you. As always, happy flying.